All right, welcome everyone. Thank you for joining us today. Today's topic is introducing the new boiler plant optimization program. This is a collaboration between Greening Healthcare and Enbridge, where we are aiming to identify hospitals with very high natural gas use and then work with their boiler service contracting companies to provide technical expertise as well as financial incentives and identify all ways to improve the existing boiler plant and make sure it's running as efficiently as possible rather than replacing it at a time when it might not need replacement or before considering the low carbon boiler plant replacement options that would be available. Your hosts for the webinar today are myself, Michael Pagel, Program Manager of Greening Healthcare. We also have Ian Jarvis, the Executive Director of the Climate Challenge Network, and Amdeep Deol, the Vice President of the Climate Challenge Network. This program itself, the boiler plant optimization program that is funded in part by Enbridge. The Greening Healthcare program is funded in part by the Government of Canada, and we're happy to be partnered with Ches on this, as well as the technical direction from Life Consulting, and of course, this applied research project of the Climate Challenge Network. And before we get started, we just recognize all those great companies that continue to support the Greening Healthcare program, which are Belimo, Blackstone Energy Services, EPA Ecosystem, Elliston Facility Services, Enbridge, PCL Construction, Smith & Anderson, and Thermogenics. And now to get started, I'll hand it off to Ian with the introduction and land acknowledgement.
Thank you, Michael. And as those of you who follow Greening Healthcare know, we begin every Climate Challenge Network event with the land acknowledgement, where we acknowledge with respect the ancestral and unceded territory of the Inuit, the Métis, and the First Nations people that share these lands with us. We're meeting today on a virtual platform. I'm speaking from Toronto, which is the traditional home of the Huron, of a number of people, the Huron-Wendat, the Haudenosaunee, the Anishinaabe, and the Mississaugas of the Credit River, and Toronto and lands down to the islands and up to York Region are covered by the treaty with the Mississaugas of the Credit River. We hope that all of our work, not just what we're doing, but what everybody on this call is doing and why you're taking your time to be here, will contribute in a meaningful way to our common responsibility as stewards of the environment. Next slide, please, Michael. We also begin most of our Climate Challenge Network events by reminding ourselves and each other why we're doing this, why are we here. And without dwelling too far, we're familiar with forest fires and smoke and droughts and loss of arable land and rising food prices. Climate change is the defining issue of our time. As horrible as many of the things happening in the world are today, eventually these situations do come to an end, mercifully. Climate change is not going to come to an end. We know climate change is going in the wrong direction. We're not meeting the targets that have been set. The healthcare sector is front and center with respect to climate change, both as the folks taking care of much of the human health damage that's happening because of climate change, but also as a major emitter. So healthcare is always involved, and we have great respect to all the hospitals that are working so hard to make their contribution. Every hospital has a role to play. We're not on track to meet global and national targets. And today is all about the fact that we need scalable new delivery models which can make a meaningful impact on a large scale across North America and around the world. So that's what today is all about. Next slide, please. Our world, when we think about climate change and reducing greenhouse gas emissions, always tends to look at natural gas consumption. In Ontario and many of the cleaner provinces and states where the grids are cleaner, natural gas is the biggest single source of greenhouse gas emissions and therefore the logical target. The chart on the slide looks at the potential reduction in total energy use, the largest part of which is natural gas consumption. So we know that every hospital is different. Some hospitals have much bigger room for improvement than others do. The focus of greening healthcare and of this project is, as Michael said, on hospitals with unusually high natural gas consumption, where the boiler plant is a significant part. So the savings potential is a starting point. Every hospital in greening healthcare is aware of its target savings. Again, some are bigger than others. Reducing natural gas consumption comes in two areas. One is the load side, which is HVAC system, end use, ventilation scheduling, ventilation operations, heat recovery. And every hospital there is significantly different. The measures that apply are different. The interest we have in boiler plant optimization is typically the smaller part of the gas reduction opportunity, but the measures are quite consistent from boiler plant to boiler plant. And we've yet to find a boiler plant where there aren't significant remaining potential, even if it's a new plant and even if retrofits have already taken place. So the focus today is on boiler plant optimization, which is a very significant and scalable and replicable part of the savings potential. The two hospitals that are part of the pilot project we're going through today, Etobicoke General and Southlake, you can see their savings potential there. These are the numbers with a starting point for recruiting these two hospitals in the first place. Next slide, please. So, new acronym for everybody to play with. So BPOP, the Boiler Plant Optimization Program. It's a lot of syllables, takes a lot of saying. So BPOP is our friendly name for it. BPOP is intended to be a new scalable model, which means that when we get it right, which we're close to doing, we believe, we can scale it up across every boiler plant in North America. So that's the vision. That's the goal. The definition is here. It's a structured, organized, consistent, systematic way of looking at all the opportunities. Importantly, it brings in all the players working together to come up with the solutions. So plant operators are key players in this, but facility managers are the boiler service contractors, the gas utilities are. We see this partnership between these parties as being the key to unlocking this and making it work North America wide. The pilot project began in December of 2025 in earnest and will come to a conclusion over the next couple of months with the results, much of which we'll share with you today. The next phase in the third quarter of 2026 will be a rollout to 8 other qualified hospitals, which again will have large gas consumption, large gas savings potential. And the goal beginning today is sharing what we're doing with gas utilities and industry players across North America with a view to replicating this process sooner rather than later. Again, the climate is running out of patience with us. We need scalable solutions and we need to scale them up quickly. So this is our program. This is what we're going to discuss today. Next slide, please. And beginning to look at the big picture, we're going to spend a lot of time today talking about the individual components of the boiler plant where the big savings opportunities are found. But we like the big picture as we look at a typical boiler plant here. We got 2 steam boilers, we've got economizers, we've got draft dampers, we've got sequencing controls, we've got steam traps, we've got steam pressure. We've got all of these elements that we tried to highlight here. All of these are addressed within the checklist approach that we're taking to this program. So the boiler plants are somewhat consistent. The opportunities are different, but they're captured within a range of opportunities that can be repeated from site to site to site. So this is our big picture, and then we're going to break down into the component parts. Next slide, please. So the checklist is still a work in progress. It addresses, and we're developing this through the pilot project with our friends, the industry partners with the two hospitals and with Enbridge Gas that has a great deal of expertise in this space. So the version that you'll see on the website when the pilot is complete will be significantly different from this. But the checklist aims to document the plant configuration, the design, the types of boilers, the equipment, the amenities that are already built into the existing plant. The next slide, please, Michael. And then document the operational improvements, the controls improvements, and the retrofits that apply to each individual site. We've had great success with the idea of checklists, that when you go through, you don't miss anything. I can see the principle here is that together the team, the gas utility, the plant operator, the facility manager, and the industry partner go through and look at all the measures that have been found elsewhere and check off either we're already doing this is a good idea, we're going to take a look at it, this is not applicable to my situation. So the aim is to get a consistent view of all of the operational controls and retrofit opportunities in each individual plant. Let's say the final document of this will be released within the next couple of months and will be available on the Greening Healthcare website for anybody to use, and we hope everybody will. Next slide, please. So introducing today's panel, and on behalf of Climate Challenge Network, I just want to say, as I always do, we are so respectful of the time and thought and energy that our partners across the industry put into making these kinds of projects work. We're just the facilitator of these things. All the other players on this list, we have Andres joining us from Enbridge Gas. We have Eddie and Simba responsible for the two pilot hospitals and who've put considerable work and effort in to get us to this point. The amount of goodwill is great. Paul, always happy to see you as part of this with Thermogenics, that happens to be the service contractor for the two pilot project hospitals. And again, providing, along with his team, tremendous amount of technical input. And this next section of our webinar today, our Vice President, Amandeep Dayal, he will be moderating this piece, and he will take it through all the things you need to know and all the things you should be considering doing within your boiler plants. So Amandeep, over to you.
Thanks, Ian. Michael, can you go to the next slide and then make me co-host, and then I'll switch over to my screen. Thanks everyone for joining us afternoon. So we'll start with, this is something you might have seen in some of your hospitals, is operating log. This is a key thing as your operations teams work through. Traditionally, what we have seen to date is these operating logs have generally been either sort of handwritten notes as part of the compliance exercise that's done in most of the hospitals around boiler plant. There has some improvements recently where some of these logs have transitioned into some sort of an Excel sheet. However, it hasn't reached to a stage where they have been looked at thoroughly to kind of understand how the performance has been going on over the sort of the months and the years, to understand where the anomalies are coming in and how do you look at improve the performance of a hospital. So I'm going to actually take a kind of time to bring in Simba and Addie and Paul into this conversation about operating log, because this has become a key information that is available within the operations team. But how do you use it and how do you empower your team? I think maybe starting with you and Eddie and Simba, or I'll pick Eddie start with. So Eddie, your team is working on this day to day, right? So they see these operating log. How do you sort of empower your team to take this opportunity? And right now, most of the logs that we see on your side and even on Simba's side, they are sort of handwritten sort of logs as a kind of a compliance, but not sort of a hierarchy of information that exists that could be used to further understand that. So in your moving kind of forward and moving this industry forward, what are some of the opportunities that you see to kind of use this kind of information and work with your vendor of record to apply these data and work with your team to improve this further?
Well, I think, for the most part, we empower our staff to really monitor the system, and I mean they're the experts in our field, and we ask them to review. And quite honestly, I don't know if they are getting as much as they can get out with the handwritten notes, but we do need them for compliance reasons. I think moving forward, having we'll say an electronic format that we could actually potentially even utilize for better trending applications, and I'm going to say maybe even actually throw it into AI to see if we can utilize AI to come up with, and some sort of analysis to really understand kind of the way that the boiler is operating and see if there's some tweaks that we can do over time.
Awesome. Simba, just to comment on this, like, how do you see this moving forward? When you talk to the vendors on a day-to-day basis, right? There's an expectations from the vendors around you have a service level agreement with them. How do you see this kind of information improving over the years that you can actually that would help your teams to deliver better outcome on operations on a day-to-day basis?
I think, we have to empower our teams by giving them technology, maybe tablets, so that, we're eliminating the paperwork and they're entering the data on the fly with the tablet, and then engaging our vendors on a routine basis, whether their meetings are monthly, bi-monthly, or quarterly, to sort of understand what the data is telling us, and maybe potentially seeing if there's opportunities analytically to move the building performance or the boiler performance. So I think working with our vendors, they're partners with us in making things improve in the facility department, and empowering our team to participate in some of those meetings. I think those two are important for them to work together, and as well as providing them technology to put it in place easily and listening to what they need.
Paul, bring in, like, a lot of these technology solutions starts with the vendors, right? They come up with an idea, they present it to the client, they help them make better decisions. How do you see that in your sort of boiler industry? Like, how do you see this transitioning from typical sort of handwritten notes to something more powerful, where we now have the options to kind of put this on an AI tool and then kind of have insights that are useful for everybody? How do you see that moving forward, and what can we do to improve this process in next few months to a year?
One of the main hurdles that's been removed over the last several years, and I was a part of the engagement group with TSSA and other regulatory bodies, is operating logbooks used to have to be in paper. And that's because of the way that the traditional rules were set. There's been guidance now to digitize these. And so in many ways, from my perspective, this is the historical path, the operating rhythm of the boiler plant. So if operators can now be empowered with a digital logbook, you can put markers in for things like makeup and gas usage, which you got highlighted there, that can trigger alarms when anomalies occur. So in the past, an operator would have to walk out through the plant to find a trap leaking. Now, if you put markers on this digital logbook, you will see an increase in makeup and potentially gas usage with a leaking trap. So that reactivity is going to improve dramatically, and responding to those issues is going to improve dramatically. But the hurdle of technology has been relieved from a regulatory standpoint. Now it's just about finding the right vendor to implement that digital logbook and putting the right markers in place, and the results will be strong.
Just a quick follow-up. Is that something you think the facilities have to develop on their own, or is that something the vendors could come up and then give that an option to facilities to tap into it?
There are a number of vendors. Each one is slightly customized because different plants have different quantities of boilers. Different manufacturers may have certain trend data they want to see in their logbook. But generally, this is something that's readily available today. And it's just about finding the right vendors that you like to work with that will integrate with your back-end system. Often that is part of the challenge. What's your front-end operating system? Will this integrate and provide the necessary alarms and functionality?
Awesome. Okay, and then the other key piece of this is boiler testing, which is typically done in every boiler plant. The way it's done, it's probably slightly different. Sometimes it's done to just look into the thermal sort of efficiency of the boilers, and other times there's a thorough sort of report on every element of the boiler plant. It kind of varies. What we have seen, it varies on a service level agreement. However, there's a standard recommendations that should exist and do exist in understanding the boiler plant, and the testing is a key part of that. What happens with the testings is usually you get some of these, sometimes you do get charts, in some cases you only get the numbers, but this is how the boiler testing kind of results could help you to improve and sort of your sequence of operations. So this is an example of the boilers that are tested as a part of, like, you can see their efficiency or their efficiency over the firing rate. But it also helps to know that which boilers are working at which conditions better, so you can kind of program these boilers accordingly to get the best out of each of these boilers. It is only possible, from our understanding, if you have this kind of a data. Another challenge that we see is with the boiling testing is that the you get a report as a facility owner or your operator on a kind of on a testing day or sort of particular year, but there's no historical data that's available for you to see. So maybe this is an example. What we saw in one of the sites is that when you put these boiler testing efficiencies at different firing rate on a period of on a scale of time, you get to see a trend, and in some cases you try to challenge that trend and say, what happened here? The boiler was supposed to be operating at 84% efficiency, and it kind of drops. It kind of brings the two questions, and Paul, maybe you want to jump in into this as well and give your thoughts, but it brings the two questions: whether the testing was consistent, like whether it was done in the same way what we would expect. So is there a testing protocol that has been established and given by the vendors to their different techs, so they're following the same scale or same sort of steps? Or is there's actually a deterioration of the boiler efficiency? So Paul, question to you, like typically in your kind of team's approach, what are those two steps? Like one is there a consistent sort of a testing mechanism given to based on the site? And also, what happens with the testing? Like the things, when you see the results like this, what is your natural next step in this, and how do you get the facilities involved in that?
I'm going to do my best to be succinct here, but there's a few major pieces of information that impacts one way or the other. I mean, the testing criteria is the same. The technician's going to go in there and he's going to set that boiler up the best he can. One for efficiency, but two for reliability. Now, if you look at your chart below, one of the key things to consider is the time of year, because the biggest challenge that a technician will have as he's setting a boiler up, especially after a teardown, which often happens in the shoulder season, because a hospital will have their N+1 boiler available, is we lack load. So for the technician to comfortably set up tight combustion on a unit without a substantial load in the plant, that's a very difficult balance to strike. So there's a level of coordination that we're always trying to juggle between when we can get access to a boiler and can we get sufficient load to run the entire range of combustion tightly. The second piece, and to your point on degradation, is if this all becomes digitized, identifying some of that deterioration will show up much quicker, because the efficiency from the analyzer that a combustion tech puts in the stack of the boiler is also related to stack temperature. So if you're trending things like stack temperatures and it's in a digital logbook, that's going to show up much faster, and you don't have to wait for your quarterly or semi-annual visit from your service provider to see some of those degradations in results. But I would argue that, like, while the test standard is the same for any service provider to kind of set up safeties and combustion on a boiler, the biggest challenges a vendor will face is, do you have load, and what time of year are we operating the boiler at? We're in Canada here, air densities change, and you're going to get variations in combustion because of that.
Yeah, I think it's a fair point in terms of testing these at a similar time. Like if this is also tested after in the shoulder period, then you would expect sort of a similar efficiencies as well. But I want to bring in quickly, like Simba and Addy, like how do you guys see, like what would help you guys? I mean, I see sometimes there's already a gap, like there's an expectancy around that my boiler contractor is going to come in, they will test it, and if there's anything they find, they will recommend us, and then we'll make those changes. And sometimes things get missed in that process, and then you do see at the meter the gas consumption goes up and your boiler plant efficiency goes down, and then you find out later, okay, things were missed. Like what from your sort of sitting at your position, Simba, maybe first with you and then Eddie after. Um, how do you see this information to be packaged so that you can actually make a meaningful use of this and work or enable your team to kind of make those changes?
I think the challenging part is about awareness, right? Having some dialogue, providing benchmarks where it's supposed to be, and then why we're off, and then validating that after. And I think Paul does make a good point that maybe we need to recalibrate to better understand the timing of the year that this testing happens.
Eddie?
Yeah, I agree. I think also it's you really can only understand the system when you have historical data, so you can understand the fluctuations between the two. If you notice a continual pattern of, on one particular month or one particular setup, then you can at least understand those ebbs and flows and make the changes accordingly. The only thing I'd add to this chart or this table on the bottom is either if there are significant deficiencies listed, like the pictures, is having a note so you can understand the results of that, the firing, the boiler testing.
Yeah, I think it will. That's one of the lessons. So we're studying these different boiler point. Like one of those things is that the consistency in reporting is different across different vendors. So as an industry, I think there's more work needs to be done to sort of standardize these, probably digitize in this age, and then use that opportunity to provide a comprehensive sort of a solutions to the facility owners and operators so they can actually understand that, and also it's easy for them to see the data and then make those decisions. So there's a bit of sort of a gap what we see currently, that where we are currently in terms of how the reporting is done versus what we can do to improvise and improve the system overall. Okay, continuing with that. So these are kind of the operational measures that are applicable to the boiler plant. You probably have seen some of that through the checklist in the past, but boiler tuning is a key piece. We talked about operating measures. Sorry, I just want to make sure, Michael, are you seeing the operational measures slide?
No, which slide did you want?
Operational measures. Okay, I don't know, it's lagging a bit.
Yeah, I'm seeing it, Amity.
Okay. So the boiler, sorry, going back to the boiler tuning. Yeah. So the boiler tuning, we talked about that, where the technician comes in and they adjust the air to fuel ratios. We'll talk about more of this impact on as a result of sort of the draft controls that are considered a few of the measures. The operational measure, steam pressure reset, which is one of the kind of the bigger measures, and there's some solutions that are applied on different sites. We'll talk about that as well when we look at the case studies for the Southlake Hospital. Um, Resetting the steam pressures to what you actually need it helps you reduce overall consumption in the plant. So typically we see some of the steam plants have ran all the way up to 110 psi. In other cases, we have seen those plant reset back to around 90 to 95 psi, depending upon your needs, and critically is driven by the sterilization equipment. Combustion air intake, again, you can optimize that through waste heat recovery, which has sometimes become a capital project, but it could be considered to improve the overall boiler plant efficiency. The boiler sequencing is another optimizations measure that have resulted in significant savings in gas consumption, because if the boilers are not automated, then typically sometimes manual operations bring them on at a time when they're not needed, and especially when during the shoulder seasons, it's hard to kind of judge the requirement of the building or the load, and the boiler responds accordingly. So having them automated, finding the speed efficiency spot is a key in this. The blowdown controls, we will see a couple of measures on that. Constant return, as much we can return, it helps to ensure that we don't have a makeup water and use additional makeup water. the BAS integration is a key where we're seeing some successes, big successes in integrating the boiler to the building automation system. So in the past, typically each individual boilers will run on their own to satisfy either the hot water or the steam load requirements. But when they are connected together, so they operate to maintain a common header pressure or a common supply water temperature, which then ensure that only boilers that are needed for a plant operation comes on versus all of them working at a low load conditions. Next slide, please. So let's kind of quickly go through some of the retrofits that are applicable, that are sort of measures that have been addressed in two of these sites, or that's going to be common across this program. So linkageless control, you've seen this or probably heard about this measure a lot in the older boilers, which have used the linkage controls to control the fuel to air combustions. The recent upgrades, and one of them is to upgrade this linkage controls to linkageless control.
Amandeep, my screen is still stuck on operational measures.
Okay. Do you see it now?
Yes.
Okay. Awesome. So the linkage, we talked about the linkageless control. So that's an upgrade that's typically recommended, which results in improving the fuel to air combustion ratios, and as a result, making that overall boiler operations more efficient. Draft damper controls. I'm going to bring Paul into this because this has become so typically when we see the boiler plants, one of the most commonly understood measures in a boiler plant involve improving the thermal efficiency of the boiler. That is either through adding the linkageless controls, but these measures around draft control have been sometimes overlooked. Maybe Paul, I'll bring you in. Can you maybe walk us through where this is applicable and how does that impact, especially the things you talked about, controlling this to ensure that the draft doesn't impact the ratio of your air to fuel. So if you want to elaborate on that, that would be helpful.
Yeah, so when you make an investment in something like linkageless controls, what that typically provides you with is much tighter control throughout the curve of the boiler, right? So from the high load all the way down to the lowest possible load that boiler can operate at, and everywhere in between, linkageless controls provides you precise air and fuel input to match the combustion results you'd like throughout that curve. Outside factors that impact the ability for linkageless controls to provide that precision is free-flowing unobstructed combustion air and gas on the input side. But on the output side, every traditional steam boiler, the draft on the stack is run at a slight negative. And the bulk of the older boiler rooms that we've been in typically would use a combined stack. So they'd have one large chimney or maybe two and multiple boilers going into that large stack. Well, a large stack produces draft, and it's just sitting there, static. So as the season changes, that draft increases or decreases. The way to keep tight combustion control, especially at the bottom end, so that low load where you're putting the least amount of gas and air in to make the perfect amount of steam in off-cycle conditions, so that's typically like spring, summer, fall, you need stability on the draft as well, because if you have a large vacuum pulling on your boiler, it's very hard to control combustion when you're putting gas and air in. So some of the early discussions we had where we thought we'd see better results at places like Southlake or EGH, they have large common stacks. And even in the summer, when draft is lower, it's still excessive for what the control would like to see. So if you really want tight combustion and efficiency at low firing rates, draft control is critical. And so the picture here is just a damper that sits on the outlet of the boiler or the economizer. And all it does is it trims that vacuum down. It's pressure. And it's a set it and forget it control. So as pressure changes in the stack, you get a windy day, you get seasonal lows or highs or whatever. The static pressure at the boiler is the same. And so therefore, it allows the combustion technician to set that combustion rate more consistently across the full range of combustion. And it's proving to be quite important for older hospitals, especially if you share a stack or a large stack.
Paul, do they come standard with the boilers, or this is an after install as a part of the package?
They do not. I mean, a lot of the hospitals that were putting these in, these were designed 20 years ago, and we didn't even have like linkageless controls in general is only around 25 years old or so, maybe a little older. But as we've driven tighter performance, especially at lower firing rates, this was an afterthought. The way in which you'd apply boiler plants was always let's make sure we've got plenty of draft so you don't get downdrafting of flue byproducts into the room. Well, now we're trying to rinse out every percentage of efficiency. So draft control is important and it's not often standard and it's often overlooked. And if you see anomalies in those test reports, especially at lower firing rates where your efficiency starts to wane, that's probably because the combustion technician has to set the boiler up more conservatively to manage that instability in draft, right? Because look, we're all trying to drive results, but at the end of the day, the hospital can't have like a lack of reliability. You must be up. You can't have flame faults all the time. So the tech is in a tight spot between how tight can I set this up, but is the boiler going to be reliable? And draft control is a cost-effective security measure to make that happen.
So is it for the boiler plant operators and managers out there to listening to us? Is this something as asking their service contractor to confirm first, do they have a draft control? And if it is, and then check and provide a report on that, and if it's integrated into the solution or not.
Yeah, I mean, my mental checklist would be like if I go in my room, do I have one giant chimney outside or do I have an individual stack per boiler? If the answer is I all go into one stack, definitely check for draft control. Next, ask the provider, do I have draft control? If not, I'd look into it.
Okay, awesome. Economizers. A lot of us have seen these economizers, and we understand sort of the need for them to squeeze as much of energy out of those flue gases to use that energy before we send it out to atmosphere. So the economizer has become the standard. The key thing what we notice in these is whether they're working or not. So part of your testing has to ensure that these economizers are delivering what they were supposed to. This is very kind of a simple piece of an equipment, but if your bypass damper is open and it's not working, it's just going to waste all the energy, or you're going to relieve all the energy that's available to you to be used for within the plant. So ensuring that these are regularly checked as a part of your regular PMs is a key to maximize the boiler plant efficiency in your boiler plant. Dew point control. This has become a key item as well to ensure that you don't get a premature failures in your boiler plant. So maybe Paul, do you want to touch on that as well, just briefly?
Yep. So the key principle here, and especially as you're doing a good job with your linkageless upgrades and you're now managing draft and you're rinsing out every bit of combustion efficiency you can from that boiler, if you're sharing multiple stacks and you've got nice low stack temperatures, you can start to creep into a position where up in the common chimney, the temperatures are so low that the byproducts of combustion start to condense. Dropped out. Are we back now?
Yeah, we're back.
I don't know where I got cut off, but in the event you're rinsing out all the heat from that flue gas and you're trying to get every bit out you can have a risk of condensing above the economizer. And so what the dew point controller is on that economizer, it's hard to see there, but there's actually a motor. And that motor is just looking at a temperature above the economizer. And in the event the economizer is recovering too much heat and the temperature above it starts to drop too low, it will crack the bypass open, allowing the temperature to just stay where it needs to be while still getting every bit of heat energy out of there it can without condensing.
Awesome. Okay. Again, that's another piece of measure that has to be reviewed for your existing plants and confirming that exists. If not, then this is an opportunity to include that as a measure for optimizing overall plant efficiency. Condensing economizers. So those are kind of two pictures. We will talk about those, but again, Paul bringing in, so there's an opportunity to kind of further take the advantage of this high flue gases and then maybe further integrate that solution into heat recovery chillers as you built on kind of decarbonization measures into your plant. So quickly, can you touch on that? What's the application of these, where they are, typically suited for, and for the boiler plants to consider this in-stack condensing and non-condensing economizers where it doesn't exist right now. Okay, looks like we lost the call again, but I'll touch base on that. So basically, this is in a simple concept terms, the condensing economizers is there to Paul, you're back. You're on mute. Sorry, we're talking. Can you touch on the condensing economizers? I was trying to fill you in, but I saw you back. Go ahead.
Yeah, sorry, I don't know what's going on here, but the condensing economizer operates in the exact same methodology as a non-condensing economizer. The difference being is this economizer can now take every last bit of heat out of the flue gas, pending you have a low-grade heat source to recover it. So you can see in this photo, there's the non-condensing economizers above the boiler, and then the stainless steel cylinders above are designed to take the flue gas change and to absorb condensate and recover it in a manner that will not degrade the boilers. A traditional boiler can only get to around 84-85% efficiency before you're condensing. Anybody that tells you otherwise is lying. Like thermal efficiency can't go past that because you're not recovering the latent heat energy from the condensed flue gas byproduct. So once you cross that threshold, you are condensing and you have to use that condensate to heat something in the system. So in a lot of applications and a lot of hospitals in Ontario, especially older ones, you typically would use some steam to top up domestic hot water use or hot water use. You can run the first pass of that cold hot water use through a condensing economizer, and it can do a lot of the work for you. This is just an example of a customer I worked with just the other day. They had a hot water requirement for 140 degrees. They actually already had a non-condensing economizer in place. And so they had a stack temperature around 350, 340 degrees. But they needed to heat up, 400 gallons a minute of water for just domestic use. And so we took the entering temperature of 72 degrees and just took as much heat out of the stack as we could. And that resulted in about 1.1 million BTUs that the boiler didn't have to provide to make that hot water, all from the waste heat of the unit. In addition to that, when you phase change natural gas combustion, you knock out condensable gases. And those condensable gases is CO2 and NOx, two things we're always striving to improve on. So outside of the straight business case of not using as much gas and saving the money you spent on the gas, you actually are making a difference in CO2 and NOx recovery. So in this case, they were looking at 625 tons a year and about a quarter ton a year of NOx. So these are substantial results, and it's a fail-safe application. If this thing doesn't work, you're still able to use steam to make your hot water, but it just sits as a side stream unit to collect any last-minute waste heat. And as long as you got a low-grade heat sink, you can look at implementing one of these.
Yeah, Paul, I'm conscious of time, but I'm guessing this is an industrial application, not a hospital.
This is an industrial laundry application.
So it's kind of year-round load, so these economics would not apply to a hospital.
It depends, right? Because I look at some of your older hospitals and the steady state load is consistent for making domestic hot water from steam.
But much smaller load.
For sure. But the economics are the same. So I'd argue to look out at how much capacity in steam, pounds per hour, you're contributing to making low-grade heat, hot water, and then just see how much that you can recover from heat sources that are already available.
Awesome. Okay. Again, this is an application, as Ian pointed out, this something needs to be studied for your facility if it doesn't exist, because this become a capital project, right?
Yes. A number of hospitals in Ontario do have these, and they work very well.
Okay. Blowdown heat recovery, that's very typical in hospitals to have it, but sometimes in some cases it doesn't work. So that then points out to ensuring that it is working as intended. So it takes that waste heat from the blowdown and recover that heat and then repurpose that heat back into a makeup water for your plant. Water wall combustion chambers. This is a project that's currently going on on the Etobicoke General Hospital. So maybe just Paul quickly on this. Can you describe what was the kind of the business case and why was it done or proposed at the hospital?
I mean, there's a number of you out there that still have very old coil tube boilers, whether they're thermogenics or vapor power units, and they have refractory chambers where the combustion would predominantly take place. 25 years ago, we changed this to a coil, and now rather than having radiant loss and combustion taking place in refractory, which can also emit NOx, we developed this furnace coil, which many applications now have, but older units do not, and we can retrofit those older units. So not only does it reduce your radiant heat loss, but it does increase your heating surface area and overall efficiency. Also, when you fire into, excuse me, refractory, there's so much radiant heat around the burner when when you're cutting back into low firing, technicians often have to add excess air to keep the flame cone of the burner safe. But when you're liquid cooling around the front end of the burner cone, you can achieve tighter excess air rates, which relate to efficiency, at those lower firing rates. So for those seasonal loads, you get much better performance and reliability out of the product.
Awesome. Other couple of measures, the VFDs on feed water pumps and the fan blowers, so which improves not only on the feed water pumps, it contributes to electricity savings and especially demand savings as these boilers are expected to work in winter and summer as well. So, and then on the fan blowers, it does improve the overall sort of electricity savings as well. O2 trims, we're still working in progress. And Andres, maybe bring you in. You guys have looked at O2 trim a lot in a lot of these hospitals and develop your own sort of studies into that. Do you want to sort of chime in and give us your sort of 2 cents on O2 trims that you have seen so far, the conversions in the hospitals?
Yeah, for sure. Definitely O2 trim is a measure that we are looking at and have looked at in our program. It definitely is a step up from linkage-less controls. The way we see it is it works by continuously measuring the oxygen level in the flue gas and automatically adjusting the air-to-fuel ratio in real time. And it also helps a lot with drift as well, which is what we see a lot in linkage controls and even sometimes in linkage-less controls, right? Over time, that air-to-fuel ratio isn't always fine-tuned, so there's constant maintenance or upkeep on that. And so having that O2 trim in place kind of solves for that issue. And so what we've been seeing in our program is we have supported a lot of our customers on linkage-less controls. And now the next step here is to support those customers who are looking at O2 trim. So customers that are looking to further fine-tune their air-fuel ratios in real time, and it's savings that we can definitely capture and support on our end. So definitely it's something to consider.
Awesome. Okay. All right. So that brings us to the case studies, the 2 case studies, as we talked about as a pilot project for this, for the BPOP program. So we looked at the Etobicoke journals where this is kind of their setup on this site. So there's 4 300 horsepower boilers with economizers and 1 200 horsepower boilers. They're kept with VFDs, and there's still, I think, some of the challenges are the things we mentioned, the handwritten operating logs and the steam pressure at 100 psi. There is already existing boiler blowdown heat recovery. So when you look at it sort of on an onset, there's few measures, but when you actually look deeper into the plant, you then come to find out what are the other measures that are applicable to further improve this boiler plant. This is where this whole BPOP program is around. It's not just looking at sort of the thermal efficiency of the boiler, which is how typically the boiler plant has been perceived as, but now this is going into details around each of those elements and how those are contributing to overall plant efficiency. So where it all started back in sort of the 2022, there were some measures, or 2023, where some measures were done on this site, including the linkage-less control upgrade for 2 boilers, and then November and the remaining boilers, we did start to see some savings initially, but not much. So that's where the trigger point happened as a third item, as you could see, is the corrective work needed to happen to sort of start getting those savings, because even with the conversion of the linkage-less or linkage control to the linkage list did not immediately result in savings. But then when the service contractor went back to kind of make sure that it's working, those things were then improved and changes were made and tweaks were done to get those savings. As you could see, those 2024 and 2025, there were further improvements that were anticipated or sort of that resulted in additional savings. From that, there's what was looked at is that even after those improvements were made in 2025, there's still savings to be had. So that's why this BPOP project came in to look at other opportunities. And on sort of on the right hand side, you can see that benchmarking chart, which is kind of the starting point to tell you where your hospital is. And if you're a Greening Healthcare member, you should already know your position. If not, you can reach out to Michael. But that's how we kind of start these conversations with the hospitals around the savings potential they have and where does it lie in terms of your utility consumption.
For clarity, Amandeep, the dots on the chart are monthly consumptions, and when the blue dots are below the red dots, that's savings, right?
Yes. So anytime the blue is below the red, that's your savings. And as you could see, that started to happen at number 3, where there's a corrective work start to happen.
Great.
So as a part of the program, there was an on-site meeting that happened. So where Enbridge service contractor operating team got together and looked at all the opportunity that existed in the plant, even though there were significant improvements have been made over the years, but there were still operational opportunities that were uncovered. So these are sort of the measures that are currently worked into a proposal for a business case to be considered by the hospital. So installing VFDs, economizer isolations, adding economizers, water inflow sensors, dew point control, draft control, all of the things that we talked about in the previous, they are now being considered to further improve the boiler plant efficiency at this site. So the business case is a key piece in that, in which there's a support from Enbridge for this program. There's a conversations to be had. How can you implement from the hospital perspective? Can they implement all of these? Are there budgets to do that, or can this work needs to be done over the years? So all of those conversations going to happen. So the incentives do help, which includes Enbridge as well as a significant portion of Enbridge incentive, as well as incentives from the ISO to contribute to make the business case for the hospital. The second case study in this case is the Southlake Regional Health Center. It's a similar concept here with the site visit was conducted, a similar sort of a hospital with acute care hospital. Even in their cases, a lot of the improvements have been made on the capital side. The VFDs were added, the dew point control were installed, but even after the conversations and the site visit, there was still more savings to be had in that plant. So again, when we looked at this, is all again same concept. We started to look at with the conversion of the linkage list to controls, and then the saving didn't initially appear. There were further improvements done in 2023 with the dew point control, and that's where we start to see the blue dots below the red dots, which resulted in a savings. And then this things, what we are still looking at is the savings that were anticipated didn't materialize, and that's where these conversations around BPOP came in to look at what have we missed and what can we do to further improve that. So which again resulted in an ongoing investigation, which we noticed that the current site doesn't have any blowdown heat recovery. So that would be one of the solutions, but there are options. There's a couple of boilers still do not have dew control or draft control. So those are all the measures are currently considered. So we're at the early stage of developing the business plan for this site, which will enable to implement all of these measures and result in paybacks. There was a question I think asked around what are the typical paybacks on these measures. This is going to be an outcome of preparing this business case with the support from the utility companies to provide that business case for every other hospitals to consider, because we believe these are very tangible measures that could be implemented with the payback with incentives with anywhere near 3 to 5 years, and some of these measures are even lower than that. But that analysis will be available and published for everybody to use and work with your service contractors and also work with the utility companies to establish them. Ian, back to you.
Yeah, thanks, Amandeep. So far, so good. I'm sure there's no hospital on this call that hasn't gone through this kind of process where a project would have been proposed by a consultant or by your boiler contractor. And the aim here is to bring together a number of those projects to take a more comprehensive and complete approach towards this. Then the optimizing of the business case, when we looked first at all the things that could be done, the cost was beyond what we believe the hospitals would be able to contemplate, and the overall payback didn't work so well. So the idea of optimizing the business case is a critical element of BPOP, which is the idea of a partnership. So we're engaged in conversations now with the hospitals, with Enbridge, with Thermogenics, looking at what's been proposed and saying, if this was yours, how would you configure these projects? Which things would you do? Which would you defer? So the partnership follows this kind of model that first, there are economies in doing multiple projects in the hospital at the same time. So the economies of scale, doing things at the same time is good. Marrying this up with end of life. So Etobicoke General is replacing its refractory with water wall chambers because they're end of life. So then the cost effectiveness becomes a lot more sensible. Phasing the retrofits over time, so you gain experience by retrofitting 2 boilers before you retrofit the other. The other 2 incentives matter. The electric, even though the energy savings are smaller, the incentives can be much larger, and maximizing the savings, including looking at other maintenance opportunities here. So this is the model we're working with the hospitals, Enbridge and Thermogenics on, to let's make the best package. Let's make the best integrated project that we can in each of these hospital sites. Next slide, please. I know we have a number of other jurisdictions on this call. We have members in New York, in Manitoba, in Saskatchewan, and previously and hopefully in Alberta, and we have a large following in British Columbia. So there's utilities on this call. Our intention is to reach out to you and have discuss the possibility of parallel pilot projects and rollouts that match this. We believe there's a lot to be learned from different jurisdictions. And again, we're looking to scale this up as quickly as we can. Next slide, please. So next steps from here and we're very conscious of our constituencies, the audiences that we have on these webinars. We have the pilot hospitals that are part of our panel today, and there's other staff from those hospitals. Our job now is to finish the business case. The hospitals will choose the measures that make sense financially for them to proceed with. Those will get implemented, and in parallel with everything else happening through BPOP, we'll be tracking the incremental savings and reporting back to everybody on how do they turn out. So Harry, so your question on paybacks, there'll be the theoretical payback. How did this actually work out? Historically, we've seen the savings being bigger than was calculated because a lot of operational and maintenance things happen at the same time that are tough to calculate. Then we got the 8 hospital rollout that is coming. So we'll be looking for other large gas using greening healthcare member hospitals. And so if you're interested, please contact Michael and express that. We'll be moving forward with that over the next 3 months. With every hospital on this call, we hope you found at least some nuggets coming out of this that you'll proceed with to chat with your service contractors, with your local gas utilities, and to adopt the improvements that make sense to you. And we can't be waiting for all this to happen. We need to move forward with the things that happen now. And again, we will be engaging with the gas utilities and the regulators in the other jurisdictions where greening healthcare is operational. Next slide, please. Just always a shameless plug at the end for those non-member hospitals on the call. Greening Healthcare works because of the networking effect of having so many hospitals like-minded, tracking data, working together on these things, consider whether this is the time to become part of this whole process. We would obviously love to have you, and everybody benefits from new hospitals joining Greening Healthcare, both those that are already here that get new insights, new information, and those that are joining to get the benefit of all the work that's come before. And that right on time. Amandeep, great job. Final slide is, this is us. I'm Ian Jarvis. I'm the Executive Director of Climate Challenge Network. Direct interest in how this unfolds. If you're interested in considering membership, sponsorship, Heather is the person to contact. She's very good at finding the common ground. Michael, you heard from at the beginning, is our program manager who's working with every one of the over 100 hospital sites now working with Greening Healthcare. And Amandeep, thanks for the great job of moderation, our Vice President leading our engineering group. Thank you.